Stanford University.
So hello everyone, welcome to CS 193P Friday session number 2. Today we have Ben and Eric from Yelp who are going to be talking a little bit about augmented reality on the iPhone. So here's Ben.
All right, so like you said, my name is Ben Newhouse. I'm a developer at Yelp. I'll talk a little bit more about myself later, but first I want to just jump right in. So augmented reality. So who here is familiar with the concept of augmented reality or AR? Some of you, all of the Yelp team, obviously. All right, so augmented reality is abolishing the barrier between abolishing the barrier across with you interface the digital with the real. So if you've seen Terminator, you might recall a scene where the Governator is walking into a bar and everything he sees is annotated with some form of information. So he sees a motorcycle which is labeled with its model number. He walks inside and all the girls in there basically have name tags because it recognizes who everybody is. And so, you think this is pretty far off in the future, and hopefully one day we'll have contact lenses with displays in them so that you can get this effect in real life. In the near future, you might have something where you have a projector in the side of your glasses, and that projects information onto your glass lenses. But in the now, we have things like Yelp Monocle. So Yelp Monocle is an app that we developed where you can walk down the street and you hold up your phone and you look through your phone and you can see the scene around you labeled with Yelp ratings for various venues. So why am I here and what am I going to talk about? So like I said, my name is Ben Newhouse. I'm the creator of Monocle, developer at Yelp. I'm also a senior in EE. I'm just a student here as well. Live in Robley. And then I brought along, I guess, the entire iPhone team, but I'll just introduce some of them. So we have Eric Singley, who's the product manager for the iPhone, and then Gabe Hanford. I only know their IRC handles, but he does all the lead iPhone development, and he's the reason that the Monocle runs for more than 15 seconds, because when I first developed it, there was no memory management whatsoever, and it basically just allocated away and crashed. So without his help, you wouldn't be able to really use anything. So, and what am I going to talk about? So I'm going to talk about 3 things. The first of which is the story behind Monocle and its virality. It really took off in ways that we didn't anticipate, and I think it's a pretty fun story. After that, I'm going to move into more of the technical hurdles in developing such an application, and then finally, I'm going to talk about what I think the future is of augmented reality. And yeah, so let's get started. So the story. So this is the guy who really started the story. I don't think he realized it at the time. This is Robert Scoble. I don't know if you're familiar with him. He's a pretty popular, Twitter person, tech blogger, I suppose. So the story was that I was working at Yelp as an intern last summer, and I was working on the search and data mining team. And on July 14th, he tweeted that I hear from good sources that Yelp is coming out with one of the coolest iPhone apps using the compass, Me Wants. So I'm sure a lot of you read a lot of tech blogs like TechCrunch and Mashable and all that stuff. And I think it's important to realize that a lot of that, if not most of it, is all bullshit. This is bullshit. Nobody at Yelp had any plans to do anything with a compass as of that point in time. Nobody knows where he got this little tidbit of false information, but needless to say, it wasn't in the books. So our PR team was kind of puzzled over this, and I thought to myself, if I sat down, I could probably do something cool with the compass. And so that night, I went home. I bought a giant can of Red Bull fit for the Hulk, and I coded until 6 a.m. in the morning. And about 6 or 7 hours later, I had my first mini Monocle. So what you see here, basically what I did was I set up an iPhone app in which there was always a teapot floating above you at always north of wherever you were. And it responded. You could look up and down and tilt side to side, and that Monocle stayed in the same spot. And I had also done this, it's also important to note, without any previous real app development. So I went from 0 to this in about 6 hours. And I think that's largely attributable to some of Apple's great documentation and examples. A lot of this is just pulled straight from various examples. So I went to work. I worked on whatever search feature I was working on. I went home and I did the same. I rinsed and repeated. And at that point, I had hooked into the Yelp public API since I was doing this on my own time. And I had gotten somewhat kind of pathetic-looking text rendered into OpenGL. So you can see this is actually taken like X months later, but this is in Robley, so you can see net appetit is labeled roughly where it is in the real world. So that was all good and well, and I kind of kept it to myself. And at some point, I don't remember the exact conversation, but somebody at Yelp brought up augmented reality, and I said, I think there's a lot of potential there with Yelp. And I actually have a prototype right here. And they're like, whoa, okay. And everyone looked at that, and they're like, why don't we put this into the iPhone app? And I was like, whoa, okay, I've been developing on an iPhone for 2 days, and I'm going to be an iPhone developer. So I was excited, and so I basically got the go-ahead to work on this during regular work hours. And we worked away. We were working against a deadline to get a big release out. So it was a lot of long nights. But this is approximately what it looked like a couple weeks later. You can see I've got search. I've got a couple categories at the bottom. This is in the Yelp office, kind of holding the phone sideways. And a little radar map as if you were playing Counter-Strike or something up there. So, this was a little rough, but we decided because it was so rough, but because it was so cool, we would put it in the app as an Easter egg. And so the idea was that you downloaded the app, and if you knew about it, then you would shake the app 3 times, a message would pop up and say, Monocle is activated. Yelp thought reality was boring, so we augmented it. And you could click Monocle button, and you would get something like this. So, we left it for people to discover, and we released the app. A day after the app came out, Robert Scoble, who you might recall from earlier, posted this on FriendFeed. You can read it. New Yelp iPhone app is also out. There's a cool Easter egg. Here's how to do it. And so this is at about 11:30 in the morning. And I think actually Scoble got on a plane immediately as he was posting this. So that allowed the media to just jump on this. And it's really amazing when you have one of these moments where you see the social techie entrepreneurship world just jump on something. So Mashable, one of the girls at Mashable filmed a video on YouTube of demoing this in which she gets a phone call in the middle of it. Because she's so impatient to get this online first, she does 0 editing of it. So the first YouTube video is her demoing this, and then she gets a phone call in the middle. And awkwardly, doesn't censor out the phone numbers, so I'm sure she got a lot of inappropriate texts that day, et cetera. So, the media continued to just jump on this, much to our surprise. And, an hour later, it was a trending topic on Twitter. There were 60 people tweeting it a second. This is pretty low. It got up to about 2 or 3. And it was quite a whirlwind of a day. And, 6 or however many months it is later, we're still getting a fair amount of press for it. There's a smattering of places with original articles on it. It's been quite a trip. So what made Monocle viral? I think a lot of people developing on the App Store want to do something like this. And I think the 3 key things, which are actually kind of all the same thing, make something cool. You want to make something that people want to show their friends at bars. I had a number of people say to me, oh yeah, I was out and about in San Francisco, and somebody pulled up the iPhone app and was showing it to all their friends, which I found bizarre because I don't show any of my friends my iPhone apps. But the other thing is do something novel. We were the first augmented reality app that really hit the iPhone, and that was a huge selling point. And then finally, make something that can only be explained by magic. So I don't think a lot of people realize all the complex sensor imagery that's in an iPhone. And so when you show them something that recognizes where you're looking at, people just are completely amazed. And then finally, what else can we take away? If you're famous enough, maybe one day you too can have a lowly intern be your genie and do your bidding. So that's the story. So now I'm going to move on to the more technical parts, which I guess is more related to this class, and things under the hood. So before I talk about some of the technical challenges that we faced, I want to kind of give you a picture of what it was that we wanted. So an ideal user experience is I'm walking down the street, I know nothing of where I am, I pull my iPhone out, I look at a business, and perfectly where that business is in the view is a label that says, this is the Sentinel. It's rated 4 stars with however many reviews. And I can click on that and find out more information. And so the things you have to get right, you have to know where the person is, you have to perfectly respond to the user's input so that the label stays in one spot, no matter how you orient your phone. Because you want it to come across as something like outside of your phone that's being annotated, not dependent on who you are. So the first challenge of that is that Monocle uses basically every subsystem that the iPhone has, with the exception of audio. So we use the GPS, we use the camera, we use the compass, we use the accelerometer, we use OpenGL and the graphics subsystem, and we use, obviously, the network as well. And in the end, it's probably one of the most battery-sucking apps on the App Store. When I develop this and I tend to run it for a long period of time, my iPhone will get like blazingly hot, which you can, which you might relate to on a laptop, but on a cell phone to get like blisteringly hot, it's pretty fun. So, the solution to this is just read lots of Apple docs and Apple examples. For the most part, everything is there. Like I said, the first Monocle was pulling basically bits and pieces from various Apple examples. So there's an example called GL Gravity, which has OpenGL and the accelerometer in it. And it's a great kind of basic thing to get things working. Now, the only controversial part of this was the camera. And if you were developing iPhone stuff 6 months ago, there was a lot of controversy over getting access to the camera. So the problem was that you could get access to the camera, but you always had this hey, take a picture button on the bottom. And a lot of people had used private APIs to crawl into the view hierarchy and hide that. And that's not allowed. That'll get you kicked out of the App Store in no time. And so we wanted to actually be in the App Store, so we just covered it up with something that was more useful. So we put a bar on the bottom that said, pick a category, bars, restaurants, and everything. And so in the end, there were no private APIs that were harmed in the making of Monocle. So the second challenge is sensor data sucks a lot, and it's noisy. It's often just completely wrong, and it's something that you really have to do some deep engineering to get around. So the first example is GPS. On a really, really good day in San Francisco, you can get plus or minus 40 meters of accuracy. That's like 3 to 6 storefronts. So that's not good at all. So here's something that I took in my dorm, actually, which is that way. But you can see it's probably maybe a couple hundred yards off. And this can kill the experience if you're standing on a street, but the GPS thinks you're standing outside of the street, and then the two sides of you all of a sudden become one. So what we developed for this, which is still being deployed, is basically a geocoder from scratch. So if you used geolocation services, they all rely on a geocoder. And what a geocoder does is it translates from here's an address, what is the latitude and longitude of this, and the opposite, here's the latitude and longitude, what is the approximate address. And so before we built anything and we were just using Google's standard geocoding stuff, this is basically what happened. You can see that there's say the blue dot is me and the red dots are the businesses on the street. Everything is on one side of me. And a problem is that with a lot of geocoders, they just put businesses straight in the center of a street. But when you're walking down a street, you're not walking through businesses. Businesses are on either side of you. And so using a lot of basically entirely public government data, I built a geocoder from scratch that could solve this problem in 2 steps. First of all, it re-geocoded all these businesses, and it moved them slightly away from the street. And then second, we had it so that we could, given a position, estimate what street you're actually on and kind of snap you onto that street so that you could guarantee that you're standing between venues. And then finally, a kind of very brief sensor tip. If you're using an accelerometer, it's also noisy, and you'll probably want to do some sort of smoothing. This is an example I actually pulled straight from the Apple docs. This is taking a moving average. So there's a lot of kind of transient noise in the accelerometer, but if you do something like this with a moving average, you basically can extract purely the gravity vector. And the gravity vector is a vector that always points down. And from that, in doing a lot of trig, you can calculate, OK, I am rotated this way, looking up that way, et cetera. So that's that. So the third challenge is, it's not immediately obvious, but there's a lot of math going on, and math is hard. So this is something that I pulled from a wiki page on quaternions, which ended up being like this huge solution to a problem that I had spent hours and hours trying to like do without the math because I didn't realize such math existed. And so, the crux of it was that we needed to use quaternions. So basically, we get all this orientation data, and we have to somehow transform it and tell OpenGL how to rotate yourself. The problem is, if you're doing rotations, if you do them sequentially, you can end up in completely different places depending on the order in which you do those rotations, and also end up in something which is called gimbal lock. And the kind of, I guess, most evident way or most intuitive way of understanding this is if you've played a flight simulator game and you're flying along and you fly up and your flight simulator will go like stalling, stalling, and you'll like drop out of the sky spinning around in circles. And the reason for that is you can think of, I have my axes here, and if I rotate around, say, this finger, I can get myself in a situation where two of my axes of rotation become one. So I lose a degree of freedom there. And that's called, like I said, gimbal lock. This is a huge thing that you come across in aerospace. There was an Apollo mission where they ran into this, and they had to completely redesign all of their stuff after they had put it in space because they realized that they were going to get themselves into gimbal lock. But if you know about it, you can just plug it in, and it works for the most part. So be aware. And then another thing is that when you're doing gravity calculations with trig functions, if you have very small numbers, then when you take fractions of small numbers that are within the margin of error, you just get complete noise. And that'll just send you spinning around like crazy. And it's not a good experience. So what you need to do is you need to be aware of that and switch the bases upon which you calculate all these orientations on. It's probably a little bit vague until you actually go and calculate it, but keep that in mind. And then kind of an obvious thing, when you're doing things at 30 frames a second, any memory leak that you have will kill your program in 15. So yeah, you have to get your memory management down. The fourth challenge is OpenGL is hard. So I hadn't really done any OpenGL before this as well, so it was kind of a rough learning curve. And so the specific things, I mean, it's pretty simple to get like a box that rotates or a polygon. But in order to turn it into a usable experience, there's a lot of stuff middleware that you have to kind of build. So the biggest problem was we have a bunch of polygons rendered in the scene, and how do we make it such that people can click on things? So if you've developed with UIKit, you add a button to a UI view, you set the selector for the callback, you get this nice pointer to a struct with this is where they clicked, this is what they clicked, this is when they clicked, etc. You get none of that in OpenGL. In OpenGL, here's a buffer, somebody touched X and Y in a 2D space, good luck mapping that to 3D. So there's really two approaches to solving this. The first of which is my mic, cast an array straight out in front of you and calculate intersections between all the objects in the scene. That requires a lot more geometry than I feel like I want to get into, and it's kind of computationally inefficient. So the other way that I kind of figured out, which turns out to kind of be standard practice, I guess, in the graphics industry, is when somebody touches something, I swap out all of the textures with basically color codes for each object. So the pen over here is blue, the hat over there is red, and then I read the pixel under which the person touched, and depending on the color, I can figure out what they clicked on. And this allows you to get amazingly complex geometry, and you have to do basically zero math. And so the key API calls, if you're doing this kind of stuff, is GL read pixels, so that tells you what color is at a given point in the frame buffer. And then kind of not related, but also to OpenGL, is something that we use is render in context. So if you look at Monocle, you'll notice that what we render in the 3D world is the same stuff as we render in various other parts in our app in the 2D. and they're full-on UI views with all of your UI view hierarchy. And there's this really nifty function call called render in context, which will basically render that all to a texture, which you can just pipe into OpenGL. And then the final thing with OpenGL is, the iPhone is impressively powerful, but it's not a desktop computer. And so you have to be really careful and really smart about your usage of everything. So one of the ways in which we optimize is we basically only use one texture for the entire program. And we blit everything into this one giant texture. That's called texture atlasing. There's a whole slew of things that you can do to optimize a lot of this stuff. There was a good, actually, special iPhone lecture last year that I looked at to figure out what I should talk about that was all about optimizing OpenGL. That talked about atlasing and some more general things. Basically, you want to make as few calls to OpenGL as possible, so you try to crunch all the data together. So that's that. Before we do that, you want to talk about, so Eric, who's my product manager, kind of oversaw a lot of this and told me when I was doing bad things and good things.
Cool.
Yeah, go for it.
All right. So what I'm going to talk about is far less interesting than what Ben had to say, but I'll be brief, I promise. So I was the product manager for our iPhone app, and that means a number of different things, but the gist of it is I spent a lot of time making things look pretty and also pestering Ben and Gabe and letting them know when we wanted to release this thing. And what we did is spend a lot of time on is, Ben touched on this earlier. I think one of the most powerful things about augmented reality in general, and I think part of what made Monocle captivating for people, is that it's simple, right? I mean, if the Yelp app is simple on its own, but if you want to search for businesses, it still takes some amount of work, right? But with Monocle, you open it up, you hold your phone up, and you're done, right? You spin around, and you've got all the information right in front of you. So we had a couple versions of the design, and I think there was even a version before the one on the left that didn't have the bars at the bottom. I think we might have just had a black bar. We've got this search field up at the top. It's a subtle difference between the first and second screen, but I think there's at the beginning when you're building something like this, there's some desire to build in as much functionality and flexibility as possible, right? So sure, people might want to search for dentists in augmented reality, so you give people a search box and they can search for it, and then dentists will pop up. But that's going to happen, maybe once in 1,000 times people are using Monocle, right? What people really want are bars and restaurants, and because like Ben said, that's what people want to show their friends at a bar, right? You want to see things that are bars and restaurants that are around you. So we took out the search box. We don't need that kind of complexity. The restaurants, bars, everything. If you really want to get everything that's close by, that's really close to you, and strip everything down. Just turn down the colors a little bit on the bar, keeping the focus on the main event, which is the businesses that are kind of magically floating around in the air. That's what people want to see, and I think anything that you can do to remove features in the name of making something a little bit more magic, I think is always worth doing, and optimizing for sort of the 80% case, which is what we tried to do. Cool. So the other thing that we spent a lot of time worrying about was data quality, especially at the beginning. I think initially one of our hesitations about even building something like this is that there's a lot of things that need to come together for something like Monocle to work, right? Ben talked about how the sensor data sucks, right? And that you really need to rely on the sensor data, particularly the compass and GPS, and those things are imperfect. In addition, Yelp has great business data, but our business data is imperfect, especially when you're dealing at this level, right? If your business, your lat long is 20 feet off, that business is going to appear next door to where you want it to. So we were worried that it was just, this really wasn't even going to be worth doing because all these three things would collide and you wouldn't see things where you expected them. I don't remember where this was in the process, but at some point Ben did a little prototype using Street View. So he pulled Yelp business data onto Google Street View and overlaid it just so we could get an idea for how accurate our business data actually was. And it turned out it was pretty good. Most of the time, especially in big cities, things were looking like they were decent. So we spent a lot of time on this. Ben, I think this is where Ben spent an immense amount of his time. Like he said, he's pulled all the center data together and did some very sophisticated things with the geocoder, all in the name of really caring a ton about data quality because we're extraordinarily anal about things like quality. So we wanted to do the best we could with what we had. At the same time, data quality is really not all that important. So we worked as hard as we could to get the data quality to be great. But what we discovered when people started using this thing is that people are willing to overlook quite a bit, and in addition, we sort of designed around it a little bit. You'll notice that in our little callouts here, we're not pointing to anything. We don't presume to know exactly where a business is. We just know pretty much where it is. And so these callouts, they're pretty big, and they can kind of float kind of near a business, and that totally works for people. Someone sees the name of a business floating somewhat near where the business is. People are in. They're excited and they totally get it. And so there's a couple things that I think work to your advantage there. Is one, the iPhone screen isn't gigantic and our callouts are pretty big, so you have a little wiggle room there in terms of how you're representing the information. Also, people's sense of direction isn't all that good. So if the compass is off by 20 degrees, and someone says, yeah, that business is roughly over in that direction, that's good enough. So as anal as we are, and frankly, I was worried that people were going to see Monocle and think, nah, this thing really doesn't work all that well. I hardly ever hear that, even though when I'm looking at something very, very critically, we're sometimes off on things, but generally people don't seem to care because the experience is good. That's all. I think that's all I'll touch on the design front.
Yeah, I have my own mic. All right, so that's a little bit about product management that went into this. Where's my the future? All right. So that being said, we've got this. We made this product. We had a pretty impressive run with it. What is the future? And I'm going to talk more about augmented reality in general, and what I think is the future for that. I think it's hopefully pretty obvious. The future of this is really in computer vision. There's an insane amount of cool work being done at places like Stanford that just are kept behind closed doors on data centers or somewhere not consumer facing. But I think with the amount of power that you have on mobile devices like iPhones and Android phones, that I think this could really become the year for computer vision on consumer devices. And I think this is going to largely happen in two kind of branches. So when you think about how we look at the world around us, we kind of do it one of two ways. We either recognize an object immediately, just because our brain is that awesome, or if we don't know what an object is, we look for text which basically labels and tells us what that object is, right? And I think the algorithms and technology around augmented reality will branch kind of into these two. So on one side, you have OCR, optical character recognition, which basically looks for characters and reads them. And the other side is general recognition. So OCR has actually, in the past, been one of the great successes of artificial intelligence in the modern world. So all of your postal mail, the addresses are read by a computer, basically. And so that works great on documents, but it works pathetically when you get out in the real world and just here's a picture, find all the text in that picture. So there's really two steps there. There's segmentation to find the text, and then there's recognition. Recognition is more or less a solved problem, but segmentation, there's a lot of work that still needs to be done because it can be quite computationally intensive as well. So if you want to look more into that, the two big things for recognition is neural nets and k-nearest neighbor stuff. Segmentation, like flood filling and edge detection, basically, are the two things you look for. And so the other part of that is general recognition. So this is an object, what is it? And this is actually farther ahead than you might think. So face recognition is doable. Like general photos and logos is doable. On an iPhone, you can get SnapTel, which will take a picture of a book, and it'll find that book on Amazon. And on Android, there's Google Goggles. And then where it starts to fall apart is for arbitrary objects. So this is a pen, this is a hat, this sort of thing. Something that can have a variety of different textures, basically. But I think there's a lot of consumer applications that don't require that kind of intelligence. So if you're more into that, keywords you want to look for are SIFT and SURF, which are used in kind of the here's a book, find that book on Amazon kind of stuff. Structure for motion, which is, I think, a really cool part of computer vision where you can basically scan around with your camera, and boom, you have an instant 3D model of the room around you. And then PCA is what you use for face stuff and 1,000 other things. And then deep belief nets too are another kind of academic-y term for a kind of an advanced version of a neural net that has some memory. But now, this part might get redacted by Apple, but I'll try to make it. OK, so you can do a lot of this computer vision stuff now. If you read on the internet, there's a lot of stuff that says, oh, you can't get access to the camera APIs. And that's true. You can't get access to public camera APIs, but you can mess around with this all you want privately. So if you do want to do public stuff, Apple has kind of said, OK, you can use UI get screen image, which used to be a private API, to basically take screenshots of the video camera view, and then you can do processing. The problem is that you can't then again label anything on that camera view, because then when you take a picture of it, your label is going to be in your picture. So this is not very ideal. But you can actually get raw frame buffers from the camera at a very, very low level. I won't tell you exactly how to do it. I don't actually know anybody else who's independently discovered this, but outside of people in Apple, presumably. But if you go and you run strings on like compiled stuff in your SDK and look for IO surface stuff, you can get access to all those things. Class dump won't work because that's too high level. All this stuff is done in C. It's not in Objective-C because it's really low level. So like this is an example of an app that I have that's basically doing live edge detection on the video stream. So this is in my dorm room. You can see I have a desk and a monitor and some things on the wall, and that kind of thing. And this runs in real time. Yeah. But that being said, like, there's no way in hell you're going to get this in the App Store at the moment. But I still think it's inevitable. And if you write your software right, so all your algorithms just take, here's a pointer to a frame buffer and a size of this frame buffer, then you can develop algorithms that'll run on anything. And so when Apple presumably finally does give you access to the camera API, you'll be ready to go from the get-go. So that being said, that's more or less it. I should emphasize that, like, I don't think it'd be hard to pull off something like this at a place. Besides, there's a lot to be thankful for, is what I'm saying. Yelp has a lot of great content. I could have gone and released this on my own, to no avail, because without Yelp's content. Furthermore, there's, like Eric pounding me over the head saying, like, simple is king. And that's what users really like. And then somebody like Gabe, who's, like I said, is the lead iPhone guy, who actually knows how to code on an iPhone. Like I said, I didn't really know anything. And so the fact that it runs for more than 15 seconds and doesn't segfault is due to him. So, and I guess I'm supposed to give a pitch too. I mean, Yelp is hiring. We're a pretty small company. It's growing fast. I worked there as an intern. I still kind of work there part-time. And I'll be full-timing sometime soon-ish, maybe next quarter. We'll see if I can get out of classes. Yeah, anybody have any questions? 0. All right, well then, the end. Thanks, guys.
For more, please visit us at stanford.edu.